All right, so the problem we're going to be working on here, guys, okay, bus travels 100 kilometers north in 1.2 hours, then turns and travels 62 kilometers south in 0.9 hours. I want you to find me the average velocity of the bus over the whole trip. Okay, now, yesterday, the problems you worked on at the end of class there were all using distance and speed, all right, which are what kind of quantities? Scalar, okay? Velocity is a vector quantity. Does direction matter for that one? Yes, it does. All right, so I'm going to give you a minute or two to try that one, and then we'll go through it together. All right, so let's have a look at this. The big thing to remember is that this trip has two parts, okay? And we did a two-part question yesterday as an example. It involved scalar quantities, but for all intents and purposes, the way you solve it is pretty much the same. Okay, what I need here is information from each of the two parts. So I'm going to write that down as my givens. Okay, for part 1, I know that the bus has a displacement, this time, not a distance, okay, of 100 kilometers north. Okay, and I know that it takes it 1.2 hours to do that. Right? I know for part 2, okay, the displacement is 62 kilometers south, and that it takes 0.9 hours to do that. All right, if I wanted, yesterday when we had that two-part question, when I wanted to find average speed, what did I do? Alicia? Exactly. Okay, I used the total distance traveled over the total time. I added the two distances together, added the two times together, and divided them. All right, because that's how you get the average for speed, for velocity, doesn't matter. Okay, we add up everything that goes along, and we divide the totals. All right, now, here's what I have to consider. I can still do that for this. It will still work, provided I reflect that one of these is north and one of these is south. Okay, I can still add them together, but what is south compared to north? Opposite or negative. Mathematically, I have to apply signage, okay, to each one. I would make north positive, I would make south negative, and that's how I would get my total displacement and total time. Average velocity is total displacement, okay, over total time. So the total displacement is going to be 100 plus negative 62 over 1.2 plus 0.9. Right? So what I should get here is 38 kilometers north over 2.1 hours. Everybody okay with that? We call that vector addition. Okay, very simply. Okay, when you're doing vector addition, you apply positives and negatives to things so that you reflect that they are different directions. All right. So now that we do that, 38 over 2.1 should give me 18.1 kilometers per hour. And because velocity is a vector quantity, I do have to reflect that this did end up north. Had that number been negative, I would have put south on. All right. That's the place where people typically will lose marks on a question like this. They'll leave that as positive. Is positive what you were given in the question? Your answer always has to reflect the vectors you were given in the question. Oftentimes people say negative 18.1 kilometers or positive 18.1 kilometers an hour and forget to put the actual direction given in the question. Okay, does that make sense? Okay, similar to what we did yesterday. Anytime you have a question that has more than one part, this is how you solve it. Okay, total displacement over total time, or if it's asking for speed, total distance over total time. All right, so really, they don't work that much different. Right? The only thing to keep in mind is that sometimes you might backtrack, okay? And in which case then you assign a negative to the backtracking direction. All right. Any questions from the front side that you started yesterday so far? All right. What I want you guys to do is work on that. Finish. I'm hoping you'll finish the front side. We'll be able to go through a few that give you trouble, and then we'll move on to the back side, which are more like this, where direction will matter. Okay? It says on their vector quantities worksheet on the back. Okay? And that's where v equals d over t will become v with the arrow over top equals d with the arrow over top over t. Okay. All right. Don't be afraid to ask if you got questions, guys. Okay, guys, the question just came up for number 7 here, so just want to address it because lots of times people look at this number and don't know exactly what it means. Okay, this is what a stopwatch would read at the end of Saeed Ayueta's world record 1500 meter, 3 minutes 29.46 seconds. Okay, not 3 hours and 29 minutes and 46 seconds, in which case it would be a world record for the slowest 1500 ever. Okay, people can run a marathon considerably faster than that. Okay, so that is 3 minutes 29.46 seconds. Okay. Okay, guys, we're gonna have a look at number 4 here. I've had a bunch of people ask about it. Number 4 is exactly like the one we did at the beginning of class. It is a 2-part question. Okay, so there is a part where it's traveling one speed, and there's a part where it's traveling a second speed. Anytime we have a question with more than one part, we have to use total distance over total time. Right? The issue with this question is it doesn't give you the times. You have to find them first. All right, so here's what we do. Okay, we start out with separating it into the 2 parts as writing down our givens. All right, so in part 1, the distance traveled is 11,000 meters. Okay, I'm going to convert it to meters right away because my speeds are given to me in meters per second. So I can't use kilometers and meters per second because that's apples and oranges. All right, so I'm going to make my units for distance match the units in my speeds. All right, the speed for part 1 is 21 meters per second. For part 2, the distance traveled is 1.0 kilometers or 1,000 meters, and the speed at which that is traveled is 4.2 meters per second. I want to find the average velocity, and I know that to do that I need total distance and I need total time. The issue here is I don't know the total time, right? But that's okay. I can find it. I know d and v for each of the 2 parts of the trip. All right, so I'm going to manipulate v equals d over t for t. Okay, so t equals d over v. Okay, that's 11,000 meters over 21 meters per second. What does that come up to? 523? 3.8 seconds. All right, so that's the time for part 1. Okay, I have to do the same thing for part 2. T equals d over v. Okay, and that'll be 1,000 over 4.2, and that's going to be, what, 200 and some seconds? 238 seconds. Okay. So my total distance is 12,000 meters. 11,000 plus 1,000. Okay. My total time is 523.8 plus 238, so that is going to be 771.8. 761. See, that's 761.8 seconds, and this is meters. All right. When I have that, then I can just punch it into my calculator. Okay, so 12,000 meters divided by 761.8. Okay, 15.8 meters per second. All right, 15.8 meters per second. Now, on here, as I've said to a few people, this used to be a vector question, and I forgot to take the vector off the answer. All right, because obviously you don't know whether this is north. It never tells you that anywhere in the question, so it would be impossible to put north on there and be accurate. But it's just that it used to be a vector question. I took the vectors off and forgot to take it off the answer. All right, does that make sense to everybody? Okay, any question with 2 parts is done in the same way. So when you get to the question about the parachutist, okay, it's the same thing. Any other ones while I'm up? Okay, keep her going, guys. All right, so for this one here, guys, we've got 3 different parts to this trip. But the difference between this one and the other multi-part trips that you've done, okay, is that this one gives us the overall distance and the average velocity for the whole trip. Which means if I know the distance of the whole trip and the average speed of the whole trip, what can I find about the whole trip? The time, right? I'll know how long the whole trip takes, and I need to find that first. All right, so we'll break it up here. Total, okay, part 1, part 2, and part 3. The question overall wants us to find the velocity or the speed in part 3. Okay, so in total, I know that the average speed is 60 kilometers, or sorry, 40 kilometers per hour. Okay, and the total distance of the trip is 60 kilometers. So time equals d over v. The time for the whole trip is 1.5 hours. Everybody with me there? Okay. Now, for part 1, it says that the car moves at a speed of 25 kilometers per hour. Okay, and that's 15 kilometers. Okay. And then in part 2, it tells me that 62 kilometers per hour, okay, for 32 kilometers. And then we only know that the last part is 13 kilometers long. Okay, if I want to find the speed for part 3, what do I need to know about part 3? The time. I can't find the time for part 3 right now, but I know how long the whole trip takes, and I know v and d for the other 2 parts. What can I find about part 1 and part 2? Time. Okay, if I know the time for part 1 and part 2, and I know that part 1, part 2, and part 3 add up to 1.5 hours, can I find the part I'm missing? Yes. All right. So time equals d over v for part 1. All right. And when we go 25 over 15, we get 0.51 or 0.6. Okay, 0.6 hours. For part 2, t equals d over v. Okay. Time for this one is 0.516. Is it or 512? Okay, I'm going to leave it at 516, though. I'm going to leave some extra decimals there. Okay, 516. Now, if I add these two together here, I get 1.16 hours. Okay, everybody follow me there? Sorry, I get 1.116 hours. Maybe I should just stop doing what I'm doing. Okay, so 0.516 plus 0.6, okay, gives me 1.116 hours. If I go 1.5 minus 1.116, okay, that is the number of hours it takes for the third part. Everybody follow? Okay. So the time for part 3 is 0.3, what was it, 0.384? 0.384 hours. Can I find v if I know d and t? Yes. Okay, so v equals d over t, 13 over 0.384, and that should give us our 34.2 kilometers per hour. All right. So it's basically just a question that I put together to make you do as many v equals d over t calculations as possible in one question. Would I ever give you a question like that on an exam? No. Okay. Do I need to see if you can do 4 different v equals d over t calculations in one question on a unit exam? No. Okay. I don't need to know that. I would just ask you one, probably in the multiple choice, because a v equals d over t question is not worth 5 marks on the test. Okay. Just understand that, you know, it's just for practice. Okay. It's to make you do as many as I can make you do. All right. Questions there? Yeah, Julia? On the next page, okay. Got to open up the next one here. Oh, I don't have it here. Hang on, guys. We got to find it. Okay, so on question number 1 here on that sheet, okay, the person's riding in the elevator. She goes up 260 meters, then goes down 150 meters. The whole trip takes 240 seconds. What's the woman's speed? Okay, well, remember that speed is total distance over total time. All right, well, her total distance is 260 plus 150 because distance is a scalar quantity and doesn't care whether she was going up or down, just how far she went. Okay, the whole trip takes 240 seconds. All right, so we've got we're looking at 410 meters. Okay, over 240. Okay, and that gives us 1.71 meters per second. And there should not be an up there on that answer because it is scalar. Speed is scalar and it does not have direction. All right, so there shouldn't be an up on that answer. All right, for the second part, it asks, what's the woman's velocity? Well, velocity is a vector quantity. Velocity is the displacement of the woman over the time. Okay, so in that case, then we have to say that she goes up 260 and then goes down 150. We have to reflect that there is direction now, and it is important. Okay, over 240. All right, so we're left with 110 meters up over 240 seconds, and when we do that, we get 0.458 meters per second up. She still ends up from where she went, or from where she started, sorry, which was ground level. All right, does that make sense? So that's one that's really illustrating there is a difference between speed, scalar quantity, and velocity, a vector quantity. Okay, are we good with that one? All right, keep her going there, guys. Okay, so we often get questions on number 9 for this reason. It looks like it's one of those two-part questions where you have to, add the total distance and the total time. But in fact, it's not. It's asking you to compare two different people running the same distance. Right? How far are they running? How far is that in meters? 10,000 meters. And that's the key because they give us the speeds of these two people in meters per second. All right? So we'll have the 18-year-old runner's information. Okay, he can travel 10,000 meters, okay, at a speed of 4.27 meters per second. Whereas the old guy, it doesn't say a 50-year-old, okay, so the 50-year-old can cover the same course. Sorry, that was the old man's time. The young guy can run at 4.38. Okay, the old guy runs the same distance, 10,000 meters, okay, at a speed of 4.27 meters per second. All right, that's not too bad for a 50-year-old guy. Okay, that's a pretty good clip actually. So what we need to do here, it says how much later should the younger runner start in order to finish at the same time. So essentially they're asking how much of a head start does the 50-year-old guy need, all right, in order for them to finish at exactly the same time. Well, if they're asking about time, what should I find out about each of these guys? How long it would take them to run the 10 kilometers. All right, so I'm just going to go T equals D over V for each one. 10,000, okay, over 4.38. Okay, and that gives me okay, 2,283 seconds. All right, then we got to do the same thing for the older guy here. T equals D over V, 10,000 meters over 4.27. Okay, so we are going to get a bigger number because he's slower. It says that it takes him 2,300 and let's say 42 seconds. Okay. Okay. All right. So how much later should the younger runner start in order to finish? Well, what do I have to do with those two numbers? Subtract them. All right. That'll tell me how much longer it takes the old guy to run. That's the head start he needs. All right. When I do that, it should come out to 59 seconds. All right. So that's not too bad for a 50-year-old guy to only finish a minute behind a young guy in a 10,000 meter race. Okay. That's not too bad at all. That's only maybe 250, 300 meters tops, okay, at that distance. So, okay, does that make sense? All right, any other ones? Number 10, yeah. All right, so you got the three-toed sloth, okay, and it's the slowest moving land mammal, so we're going to race it and a tortoise, okay. So we got their two speeds. And we know that they're both going to walk or crawl or whatever it is they do for 12 minutes. Can I figure out how far each one of them goes in 12 minutes? But what do I have to do with the 12 minutes before I can do that? Convert it to seconds. All right, so sloth. Okay, sloth's speed, 0.037 meters per second. That is 3.7 centimeters per second. about that far. Okay, pretty slow. Luckily, it has virtually no natural predators. All right, and the time is going to be 12 times 60. What's 12 times 60? 720. Okay, 720 seconds. All right, and then for the tortoise, I always spelled tortoise wrong. All right, tortoise. Okay, v equals 0.076. meters per second. Time is the same, 720 seconds. All right, I got to manipulate v equals d over t to solve for d, which means multiply both sides by t. So v times t equals d, and that's going to be 0.037 times 720. All right, so the sloth will go 26.64 meters. Okay, and the tortoise, same idea here. D equals v times t, 0.076 times 720 seconds. Okay, 54.72 meters. All right. So how much further does the tortoise go? Well, we just subtract those two numbers. So minus our 26.64, 28.08 meters. All right. It would be probably the most boring race you would ever watch. All right. To watch a sloth and a tortoise race. Yeah. The only way it would make it more exciting would be put some sort of natural predator there, and maybe it would get more exciting then. I don't know. Questions? Parker? 8? Is this one here the plane? Is it the plane question? Yeah. Oh. Well, that's on the other side. You're not supposed to be doing the other side yet. Are you done the first side? Yeah, you're not supposed to do the vector quantity side until you're done the scalar side. Okay, was that the one you were asking about, Parker, or were you asking about this question number 8? The plane? Okay. All right. So on an adjacent, so you're sitting on a runway and you're looking out of a narrow opening. Okay, the key is that your window in the plane is a narrow opening. So as you see the plane come into your window, the distance the plane travels as it goes across the narrow opening is the length of the plane. All right, from the front of the plane to the back of the plane. Okay. So the length of the plane is the distance, and the amount of time is how long it took for the plane to fly through the window, okay, or across the window for you. So the arriving plane has a length of 36 meters, and the speed of the plane is 45 meters per second. So we're looking for the time. So simply v equals d over t, but we're solving for t. So t equals d over v, 36 meters. Okay, over 45 meters per second, and that should give us 0.8 seconds. It's a little confusing, the wording of that. Okay, but that's how you would do it. Anytime you're trying to find out the velocity of something and you're watching it through a narrow opening, that's you use its own length to figure out, okay, its speed. 12? This one? Yeah. Okay. So for number 12. Number 11 is one of the two-part questions, okay, where I've got to use total distance and total time. Right? So the skydiver falls, okay, with their parachute unopened, 625 meters. Okay, so in part 1, the distance traveled by the skydiver is 625 meters. The time it takes them to do that is 15.0 seconds. In part 2, the parachute is now open, thankfully. Okay, they fall a distance of 356 meters in a time of 142 seconds. I want the average, well, it should say speed, not velocity. The average speed, well, we can do velocity here because what direction is this person moving? Down. Okay, so we can say that. All right, so velocity, magnitude, and direction for the entire fall. Well, average velocity, okay, I'm going to make these displacements by writing down after them, okay, giving them a direction. Average velocity is total displacement over total time. Well, the total displacement is 625 meters down plus 356 meters down, which should be 900 and 61? 97? 981. Okay. 981 meters down. Okay. Over the total time, 157 seconds. All right, when I do that, total distance over total time, I should get 6.25 meters per second down. Okay. Any other ones there, guys? Seems like you guys are doing pretty well here. All right, so keep her going there. If you get to the second side, remember, okay, we've got direction making a difference. In fact, I want everyone to go to question number 1 on the second side right now. Okay, and I want to just go through that, okay, as a good example. All right, so we got the person riding an elevator. She ascends 26 floors, that's 260 meters, then descends 15 floors, which is 150 meters. All right, we want to find the woman's speed and the woman's velocity. If I'm asked to find speed, does it matter whether she moved up or down? No. Speed is just distance traveled over time. How far did she travel? Nope. 150 plus 260, 410 meters. Okay, her total distance is 410 meters. 260 plus 150. The total time, they tell us, is 240 seconds. So the average speed is 410 meters over 240 seconds, and that gives us our 1.71 meters per second. Right? This should not be here on that question. Why should there not be up next to a value for speed? Well, yeah, it doesn't matter because speed is scalar. Okay, and scalar quantities don't have direction. All right, the woman's velocity. If I'm going to calculate average velocity, I need the displacement over the time. All right, to calculate the displacement, I've got to go, all right, 260 up, that's positive, plus 150 down. So that's negative. All right, you probably just subtracted them in your head, okay, over the total time, 240 seconds. So 110 meters up over 240 seconds should give me 0.458 meters per second up. She still ends up above where she started, so her velocity and her displacement are both still up. All right, so that question really illustrates difference between scalar and vector. Okay, really illustrates the difference there. We got to know that when we're doing a scalar calculation, we do it slightly different, okay, in that we don't care about the direction than we do a vector one. Okay, Charlotte? That's the total time. Right? That's the total time for the trip. All right, keep going there, guys. Okay, so for number 3 here, guys, if you're there, we got the jet that travels 350 kilometers per hour, and that's east for 45 minutes. It then hits a storm and is forced to turn around and travel west at 375 kilometers per hour for 30 minutes. How far did the plane travel, and what was its final displacement? Then what's the speed for the entire trip? Well, let's set it up and do all the scalar things first. We're asked to find speed. In order to find speed, we have to find the total distance traveled anyway. Okay, so let's break it up into part 1 and part 2. Okay, and we'll start looking at things here. So we know that, okay, in the first part, we don't know what the displacement or the distance is. Okay, we do know the velocity is 350 kilometers per hour. Right? And we know that the time is 45 minutes. But my units in my speed are hours. So what do I need to do with the minutes? Change them to hours. Well, 45 minutes is 3/4 of an hour. That's 0.75 hours. Okay, everybody with me there? Okay. And for part 2, okay, same idea here. Don't know how far it goes, okay, but do know that it was traveling at 375 kilometers per hour, okay, for 1/2 of an hour. So time equals 0.5 hours. All right, so now I can calculate D. D is V times T. All right, so 350 times 0.75 Okay, it gives me 262.5 kilometers. Kilometers, and that will be east. Okay, and then I got to do the same thing over here. Okay, so I'll have 375 times 0.5, and that's going to give me 187.5. Kilometers west. Okay, now I have everything I need in order to solve the rest of this question. So first thing it asked, how far distance-wise did the plane travel? What do I do with the two displacements I have to get total distance? Add them. Regardless of what direction they're in, add them together. All right, so 262.5 plus 187.5 should give me 450 kilometers with no direction because distance is scalar. All right. The second part says, what's its final displacement? Well, for displacement, okay, then I'll have to use the directions. I'll have 262.5 kilometers east. I'm going to make that positive, plus the westerly part, negative 187.5 kilometers. Okay, and when I do that, I should get 75 kilometers east. Okay, still ends up east of where it started, right? Because I end up with a positive number when I do that. If I want to calculate the average speed over the whole trip, am I using the 75 or the 450? 450. Speed is distance over time. Okay, so v equals d over t. Okay, and so that's going to be 450, the distance over the total time, which was 1 1/4 hours. Okay, and that should give us 360 kilometers per hour as the average speed. All right, does that make sense? Okay, now on number 4, guys, I think I have a typo here. This should be kilometers per minute. Okay, so if you're looking at that and wondering if that's why you got it wrong, I'm pretty sure this should be kilometers per minute. Okay, but we'll just double check here. So the couple rows 2 kilometers north, and then they turn around and row 3 kilometers south. What's their overall displacement? 1 kilometer south. They went 2 north, 3 south. They went 1 kilometer south overall. All right, so their overall displacement is 1 kilometer south. And it took them 70 minutes to do that. Okay, so I have d and I have t. Can I find the velocity of the canoe? Yeah, velocity equals the total displacement, 1 kilometer south over 70 minutes. Okay, and I think this, it comes out to 0.01415, right? Okay, so this should actually be kilometers per minute, not meters per minute. Okay. Okay, so number 5, two-part question. Okay, exactly the same as all the other two-part questions we've done. Okay, where we've got, okay, in part 1, the kid runs at a velocity of 6 meters per second east, okay, for 30 seconds. Okay, in part 2, the child runs at a velocity of 5 meters per second, but this time it's west, and he does that for 55 seconds. If I'm going to find average velocity, what do I need? 2 things. Total, not distance, total starts with D. Displacement, right? This is a velocity question. Total displacement, okay, and total time. Well, I don't have the displacement in either part, but I have v and t for each part. What can I find? D for each part. Okay, so got to do that first. D equals v times t. 6 meters times 30 seconds is 180 meters east. Okay, and over here, D equals v times t. 5 times 55 is what? 275 meters, and that's west. All right, so he went 180 meters east, then he went 275 meters west. Seems to me like he ended up 95 meters from where he started. 95 meters west of where he started. Okay, not east, because he went 180 meters east, then 275 meters west. He went further west than he did east. Okay, so 95 meters west is his total displacement. Well, now total displacement over total time, 95 meters west over the total time, 85 seconds. Right? Total displacement over total time. So 95 meters west over 85 seconds. And that should give us 5.35 meters per second. Right? It doesn't give you... Oh, yeah. Oh, sorry. It's what's speed? Sorry, it doesn't ask for velocity. It asks for speed. That's why it's 5.35, because his average speed is 180 plus 275. Okay, so we're not going for velocity here. We're going for speed. So we need total distance. All right, so that's going to be then 455 meters over 85 seconds. That'll give you 5.35. Yeah.